Have you ever wondered how your car just knows to lower the radio volume when the parking sensors start beeping? Or how hitting the brakes triggers a whole symphony of instant responses? Well, that's not magic. It's actually a really complex conversation happening under the hood. So today, we're going to pull back the curtain and decode the basic rules that let every single part of your car talk to each other.
I want you to look at this because it's not just a car, it's a rolling network. Seriously, a modern vehicle has dozens of these tiny little brains called ECUs, or electronic control units. Every single one has a specific job, from engine timing to your power windows, and they are all chattering away, constantly sending messages to one another. So, right away, you can probably see the challenge here. With all these conversations happening at once, how do you prevent total chaos? How do you make absolutely sure the right message gets to the right part at the right time without getting lost or, interrupted? I mean, think about it. If your brake system sends out a super critical message, like, we're stopping now, how do we guarantee the infotainment system doesn't just butt in with a now playing update? Well, the answer is a very clear set of rules. And to understand them, we're going to use a pretty simple analogy. So the very first part of the solution is all about addressing. Just like when you send a letter, the system has to know who the message is for. Is it for just one specific component, a small group, or is it for everyone? To really get this, let's imagine all these car parts are guests at a really busy office party. The way people talk at a party, sometimes in private, sometimes in little groups, sometimes making a big announcement, that perfectly explains how components talk inside your car. All right, first up, we've got something called Unicast. This is as simple as it gets. It's a direct, one-to-one communication. One sender, one receiver. Think of it like a private, dedicated line. So, at our office party, Unicast is you pulling a colleague aside for a quiet, one-on-one chat in the corner. The information is just for them, and nobody else is even aware the conversation is happening. It's a direct, point-to-point discussion. Okay, but what if you want to talk to more than one person, but not, the whole room? Well, that's where multicast comes in. This is when one sender sends a message to a very specific, predefined group of receivers. Back at our party, you can picture this easily. Imagine you're at a long dinner table telling a story. Only the few people sitting right next to you can hear it. The folks down at the other end of the table, they're in their own little world, having their own conversations. They're not part of your message's audience. And finally, we have the big one, broadcast. This is when one sender just sends a message out to everybody on the network. Now, this is really important. For the core systems in your car, like CAN and FlexRay, this isn't just one option. It's often the only way they communicate. At the office party, this one's a no-brainer. It's the host grabbing a microphone to make an announcement. Hey everyone, dinner is served! Or, thanks for coming! Everybody hears it, whether they needed to or not. It's a one-to-all message. Okay, so we've covered who gets the message. That's a huge piece of the puzzle. But there's another really critical rule we have to talk about, the direction of the conversation. I mean, is it a one-way street, or can the receiver actually talk back? That brings us to our next section. This table here breaks down the 3 ways data can flow, so let's walk through it. First, up top, we have simplex. Think of this as a one-way street, period. At our party, this is the keynote speaker on stage. They talk, you listen. That's it. Next in the middle is half duplex. Now, communication can go both ways, but, and this is key, only one at a time. This is like a debate with only one microphone. You have to wait your turn. And finally, we have full duplex. This is just a normal conversation. Information flows in both directions at the same time. You can talk and listen, no problem. And this side-by-side really just makes it crystal clear, doesn't it? On the left, you have that simplex monologue. Information flows one way from the speaker to the listener. End of story. But on the right, you've got a full duplex dialogue with information flowing freely in both directions, all at the same time. So let's just focus on half duplex for a second. The absolute best real-world example here is a walkie-talkie. You push the button to talk, right? And while you're talking, you can't hear a thing. Then you say over, let go of the button, and now it's the other person's turn. It's a two-way conversation, but it's strictly one person at a time. Okay, the party's over. Let's take these ideas from our analogies and bring them back to the pavement. Why does any of this actually matter in your car? Well, it's because every single system is specifically designed to use the exact communication mode it needs to work safely and efficiently. Nothing is random. Let's look at some real examples. A broadcast message is perfect for your engine control unit to send out the current vehicle speed. The dashboard needs it, the transmission needs it, the stability control needs it, so it just broadcasts it out to everyone. For simplex, think of your car's radio antenna. It only receives signals, it never transmits anything back. It's all ears, no mouth. And for full duplex, imagine a mechanic plugging a diagnostic tool into your car. They have to have a real-time conversation, sending a query and getting data back at the same time to figure out what's wrong. So there you have it, from those one-to-one whispers to the big all-hands announcements, and from one-way lectures to two-way debates, these are the basic rules of conversation that keep your car running. But this brings up a really important question. In a car, which is an electrically noisy place, what happens when a message gets garbled or just plain lost? How do these systems handle mistakes? Well, that's a story for another time.